So we're gonna be doing or touching the marathon class in Chem 122. Now, first of all, let's take a look at some little questions involving mole ratios. Okay, so now first of all, the question says determine the volume of air containing 21% oxygen by volume required to burn 400 of butane. Now let's take a look at this reaction. This reaction, we have a ratio 2:13. Now we're considering butane and oxygen because that's what the question asks us for, oxygen and butane. So now we have ratio 2:3. Then so let's take a look, or let's calculate the mass, the weight of this compound. We have it to be 58. Now they said oxygen is a gas, so molar volume at STP of gas at 22.4 dm³. So we have here to be 22.4 dm³. So we have butane to have 2 moles, then oxygen 13 moles. So we multiply here by 2, then I swear here by 13, giving us 400 grams of butane. 400 grams of butane. How many volume we have to burn this? We give us x. So we have this. So the value of x will be equal to 400 times 22.4 times 13, everything over 2 times 58. So this should give us a value of something close to that. Something close to this 0.14 dm³. Now this is the amount of the volume used to burn 400 grams of butane. Now they now ask us containing 21% by volume required to burn this. Now if 1004.14 dm³ was required for 21%. How many of the volume we require for 100%? Now this is 21%, this is 100%. And how many will it be? So we have it to be 1004.14 times 100 over 21 is equal to x. So x will give you we have the value to be 4781.6 approximately. Now this is the solution to question 1. Now let's take a look at question 2. It said how many atoms are present in first of all 46 grams of sodium. Now this question is something technical, like you don't have to solve directly, but you need to be observer from the question they are asking. Now it says how many atoms are present in 46 grams of sodium. Now remember that mole is equal to number of atoms over Avogadro's constant. Number of atoms would be equal to the number of moles times this. So now we're not giving the number of moles, we're giving it in grams. So converting grams to moles will be the mass 46 over molar mass of sodium 23 times 6.02 times 10 to the power 23. So this should actually give us 1.204 times 10 to the power 24. Now this is not the answer yet, because it said how many atoms are present in this of sodium. Now they said how many atoms. So sodium is Na. So how many atoms are here? Just one. Just one. So I'm multiplying here by 1, which is unchanged. Give us the same value. Assuming we have something like iodine. So if we have this, where is atomicity? 2. So we're multiplying here by 2. And let's take a look at this question. It suits this part. Question 2 said, how many atoms are present in 4 grams of oxygen? So we have number of moles. Number of moles is the same thing as mass over molar mass, which is 4 over 16 times 2. 16 times 2. So we have this to be number of atoms over 6.02 times 10 to the power 23. So we have number of atoms, the number of atoms to be 4 over 16 times 2 times 6.02 times 10 to the power 23. So what should this give us? That is 7.525 times 10 to the power 22. Now we are not done yet, because we have oxygen as a gas, which it has atomicity is 2. So we're multiplying it by 2. So we have this to be 1.505 times 10 raised to the power 23. Alright, same goes to question 3. It's actually similar to this. So question 3 says 11.2 dm cube of CO2. How many atoms are present in 11.2 dm cube of CO2? Now recall that the formula for molar volume of gas at SPP is equal to volume over amount. Amount is in moles. Now multiplying, we have N to be volume over molar volume. Now what is the volume? 11.2 over 22.4, which is actually 0.5, 1 over 2. So we have the mole, so it is 0.5. So now let's find the number of atoms. Mole is equal to number of atoms over 6.02 times 10 to the power 23. So now to multiply, we have number of atoms will be equal to 0.5 times 6.02 times 10 to the power 23. So this will actually give us 2.01 times 10 to the power 23. C. Now we have it to be CO2. How many atoms are present here? We have carbon to be 1, we have oxygen to be 2. So additional, we have it to be 3. So multiplying this, we have 3. This should give us 9.03 times 10 to the power 23. See. Now this is the answer to question 2. Alright, so now question 3 said how many atoms are present in 54 grams of glucose, and as well how many oxygen atoms are present in this. Now this is almost actually same with what we are doing here, but let's take a look at the question. It said how many atoms are present in 45 grams of glucose. Now remember we have mole is mass over molar mass. Since that they gave us in grams. So we have 45 over molar of the compound, it should be 180. Then number of atoms over 6.02 times 10 to the power 23. So we have number of atoms will be equal to 45 over 180 times 6.02 times 10 to the power 23. So we have it to be 1.505 times 10 to the power 23. Well, they said how many atoms are present in glucose. Now we have this to be glucose. Glucose is 6C6H12O6. Now we have this to be 6, here to be 12, and here as 6. So adding everything, 6 plus 6 will give us 12 plus 12 will give us 24. So multiplying it by 24, we have it to be 36, 3.612 times 10 to the power 24. Yeah. Now this is the answer to this first part. Now they said how many oxygen atoms. Now this should be actually talking about oxygen alone. Oxygen alone. So speaking on oxygen, we have 45 over 180, which is the mole. The mole will be equal to the number of atoms over 6.02 times 10 to the power 22. So we have number of atoms will be equal to 1 over 4 times 6.02 times 10 to the power 23. Which is actually 1.505 times 10 to the power 23. Now they said oxygen atoms. How many oxygen atoms are in C6H12O6? It's actually 6, so I'm multiplying it by 6. So we have it to be 0.01 times 10 to the power 23. Now this is the answer to the question. Now quickly we're going to move down to molarity, then normality. Then molarity, let's go. Molarity is actually one of the simplest among all, because it has a preferred formula, a specific formula, a specific unit, which is mole per dm cube. The unit of molarity is molar, which is the same thing as this, and so on. Now, first of all, what is the formula for molarity? Now, molarity is actually, recall that mole is equal to CV over 1000. Now, this molarity is the same thing as concentration. Now, concentration in dm cube, a mole per dm cube is molarity. So, making C over formula, we have C to be 1000 N. N is mole over V. Now, recall that mole is equal to mass over molar mass. So, we have it to be 1000 times mass of solutes over the molar mass of solutes times volume of solution. Now this is the formula for molarity: 1000 m divided by mass times volume, which is molarity is 1000 m over mv. Now the formula for molarity. Now as we go on, I'll be telling you the mole formula which we can use to solve for molarity, like the likes of stock solution and dilution. Let's take a look at number one question. They said, what is the concentration in mole per dm³, which is actually the molarity of the resulting solution when 6 grams of CaCO3 is completely dissolved in water to produce 300 cm³ of solution. Now this is the volume of solution. Now recall that molarity is 1000 m over this times volume of solution. Now this is the mass of solute, molar mass of solute, volume of solution. Now we have it to be 1000 times m, the mass, which is 6 grams, over CaCO3. CaCO3 is 40 plus 12 plus 48, which is actually 50, 60, which is 100 times the volume of solution, which is 300. Now, first of all, why the formula for molarity is supposed to be m over mv. Now this volume, if it is in dm³, this is the formula, but if it is in cm³, which is this, or ml, you have to multiply by 1000 in order to convert it to dm³, because our volume should always be kept in dm³. So now this is in cm³, so we have to convert it to dm³, so we multiply by 1000. That's why we have this formula here. So this should give us 0.2 mole per dm³. It is either you see it in this form or you see it as 0.2 m, or any of this form. Now if you are asked to give your concentration in grams per dm³, in grams per dm³, this is the formula. Molar conc, which is the molarity is equal to the mass concentration over molar mass of the solute. Now if you multiply, we have the mass conc times molarity times the molar mass. Now this is a gram per dm³, which is a mass concentration of compound. Okay, so now this is the answer to question 1. Now let's take a look at question 2. Calculate the molarity of first of all, let's take a look at question 3, then go back to question 2. Okay, they say what is the molarity of a solution of density 2.99 gram cm³ prepared by dissolving 34 grams of HNO3 in 500 gram of water. Now they say what is the molarity of a solution of density this prepared by dissolving 34 grams of Ag. This is the solute. Now this is the solvent. And recall that solute plus solvent will give us solution. Now first of all, what is our formula for molarity? Molarity is equal to 1000 m over mv. Okay, so now we have our mass to be 34, 1000 times 34 over the molar mass of AgNO3, 170 times. They didn't actually give us the volume of the solution. Now we're given the density of this compound, which says this formula doesn't suit this question. Okay, so now how do we get for this? Now recall that density is equal to mass over volume. Now to get this mass, of solution, we have it to be this is the mass of solution. Then this volume is unknown, and this volume that we have to place here, which is unknown there. So now this is the density, which is 2.99, is equal to the mass. What is the mass of the solution? My solution is a combination of this plus this. Recall that solute plus solvent give us solution, and the mass of the solution will be the sum of the solute. Solute was 34, then the solvent was 500, which will give us a solution to be 540. Now this is the mass of the solution, so we have 540 over volume. So multiply, we have the volume will be 540 over 2.99. so we have 534 over 2.99. so we have the value to be 178.6 cm cube. Now this is the volume of the solution. So we can now replace here with this value, which is 178.6. So we can now find our molarity. Molarity will now be 34000 over 170 times 178.6, which is this should give us approximately 1.12 molarity. Now this is the answer to this question 3. Now going back to question 2, now they say calculate the molarity of a 36% weight per weight solution of HCl, which density is 1.19 gram per cm cube. Now I want to prove a formula here. I want to show you a formula. That links us to both the density and the percentage for calculating molarity. Now recall that molarity C is equal to 1000 m mass over molar mass times volume. Then density is equal to mass over volume. So multiply, we have volume is equal to mass over density. So this is the volume, so we have volume here, so we can replace it to what we have here. We have it to be 1000 m over mass times, what is the volume? M over D, which is M over D. That's what we have there. So now have C will be equal to, so if, okay, let's continue. We have 1000 m over m over D. This is the same thing as C is equal to 1000 m divided by m over D. So what do we have here? We now have 1000 m times is will not be the inverse to get this, will not be D over m. So we now have molarity will be equal to 1000 md over m. So now we have common terms here. We have m and m to be common, so they cancel out. So we now have 1000 d over the molar mass. Now this is another formula for molarity. That is where the term when they are not they didn't give us the mass of the compound or neither the mole of the compound, that they gave us the density and the molar mass of the compound. Now take this as a note. Okay, now from here, now we have that molarity is equal to 1000 d over m. Okay, so now if we are asked the molarity in a particular percent, like how many, like 60% of the molarity, 60% of the molarity would be, so assuming, let's assume 60%, which is actually 60 over 100. So assuming the percentage is not known, which is unknown, we assume here to be x, unknown, like x. So we now have our molarity to be 1000 d times x over m times 100. So this is the same thing. Now we can replace it to be, this is x, so to make it known we can say 1000 d times p, let's use p because p is percentage, p over 100 m. So this 100 will cancel 20 here, so we now have c will be equal to 10 pd over m. Now this is another formula for molarity. Now is this formula that suits this question too, so that's why I have to pause. Let's study the third one, then go back to question 2. So now let's, so note that the easiest way to calculate molarity is by bringing out the parameters. Now bringing out the parameters will make you know the formula to use among all the formulas I've dropped here for molarity. Now question 2 say calculate the molarity of 36% weight per weight solution of HCl, which density is 1.19 gram per cm cube. So now we have they say the molarity is unknown, so we are finding molarity. They gave us our percentage to be 36 weight per weight. Then the density is 1.19 gram cm cube. So molarity is 10 pd over m. So we have 10 times 36 times 1.19 over 36.5. This will actually give us 11.74 molarity. So now this is the answer to question 2. So now let's go straight to molarity, then normality, and then move on to a new subheading.